This is section 4.1, Introduction to Polynomials, or to Polynomial Functions. An nth degree polynomial is a function of the form p of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 1 x plus a sub 0, where a sub n is not equal to 0. So I'm sure you've seen that before. It looks more complicated than it is once you get actual numbers in there instead of these letters, the a sub n's and the n minus 1s, etc. It looks a lot simpler. One thing that's a little different here than what you might be accustomed to is that we're allowing the coefficients to be complex numbers rather than just real numbers. And of course, this kind of depends on context. Sometimes we're assuming that the coefficients are real numbers. Sometimes we're allowing complex numbers. But in general, we allow complex numbers. So the definition: a complex number k is a zero or root of a polynomial p if p of k is 0. So a zero of a polynomial, that doesn't mean that your input is 0. It means your output is 0. P of k. Such a number k is a solution of the polynomial equation p of x equals 0. That's fairly obvious, I hope. Graphically, k is the x-coordinate of the x-intercept of the polynomial function y equals p of x if p is a real polynomial. That is, a real polynomial is one that has real coefficients, and if k is a real number. So if either of those, if the coefficients aren't real or k isn't a real number, the whole graph is not going to lie within the real plane. And so, you know, that point that you found, the 0, might not actually even be in the plane. Because if k is a non-real complex number, it won't be in the plane. So it can't be an x-intercept.